All right, you guys. Our next lesson is on inverse trig functions and their derivatives. Now, in this lesson, all this, all the way down to here is what I usually call like algebra stuff. Or, pre-calc stuff. Not algebra, but like pre-calc stuff. None of this is calculus. You want to know the calculus problems that we're going to do? There are 3. That's it. Everything in this lesson is a basic review of what an inverse trig function is. Now, I know because almost all of you had me last year, I didn't really teach inverse trig functions because we were running out of time and I was losing some time. So, I'm going to teach you today what an inverse trig function is, okay? You guys have seen these buttons on your calculator. You've used them in the past, actually. Let's see if I can pull this up here. Okay, let's see. Come on, calculator. Come on, calculator. Dude. Open. Ah, there we go. Here it goes. Okay. While it's doing that, I'm going to load something up over here. Aha, there's my calculator. Can I make this a little smaller? It did. In here. All right, cool. Whoops. Anyways, you guys, right here, these are your inverse trig functions. Inverse sine, inverse cosine, inverse tangent. Where you have used those in the past is like solving for angles of right triangles and stuff. That's only one application of it, okay? Now, look, let me go back over to this real quick, okay? Y equals sine of x, all right? There we go. You guys know it's the graph of sine. In order to get an inverse, the inverse would be basically switching x and y, right? Now, your graphing calculator won't graph this, but it will graph it for me on Desmos, okay? X equals sine y. That's your inverse. Remember, we talked about inverses make this really cool pattern. So if that's sine x, right, that's x equals sine y. But what do we know about this, guys? This is not a function, okay? This is not a function. So what happens is, like, see, every time, like, right here, where it, like, turns around on top of itself, not a function. Going through here is okay, but then here, not a function. The second it turns around on itself. So what we have to do is we have to restrict it to make it a function. And basically what I'm going to do is I'm going to erase everything up there and I'm going to erase everything down here. Now, I don't actually know if this will work. Let me try. Because we want to go with only y being less than or equal to pi over 2. Oh my gosh, this is going to work. Nope. Oh yeah, it is. Maybe. And greater than or equal to negative pi over 2. Whoa. That greater than or equal to, I put it in the wrong place, guys. I'm sorry, I'm almost there. And boom. Hey, let's go. Let me put sine back on there. Okay, that's the inverse sine function. Isn't that lame? It's a little bloop, because I had to restrict it. So in fact, if I go back onto this TI thing, okay, and I go in my y equals, and I just do inverse sine, all right, inverse sine, look at what it looks like. Bloop. It's just this little crappy, like, bloop. That's it. So lame, right? But that's what inverse sine looks like. So you'll notice that, like, for when I do the inverse sine, it goes -1 to 1, but I can only pick the points between negative pi over 2 and pi over 2. So hopefully that makes sense to you guys, because otherwise the second that happens, that's going to start curving around, and it won't make it a function anymore. So that's the points we decided to pick, was there to there. Okay? And it's just that little section of the graph, as opposed to, like, me just taking the entire inverse sine graph. I only draw that section from there to there. All right? Oh, shoot. I didn't show that. There we go. So I only draw that section from there to there. Okay? Okay, so check it out. So for my inverse sine graph, it's going to be like this. 0, 0, because the regular sine graph is 0, 0, so 0, 0. And then it goes pi over 2, 1, so this is 1 pi over 2. And then it's negative 1, negative pi over 2. And let me think about the way it arcs. Let's see. Hold on, it's going to come down like that and like that. Okay? So it's not a straight line. I'm just like kind of exaggerating that a little bit so you can see it. That's what inverse sine looks like. It's just this little teeny, crappy, only that little part right there. Okay? Okay, next. So these like range values are kind of important, honestly. They're kind of important. All right, cosine, inverse cosine. Let's take a look at my graph here. And this time I'm going to do, okay, y is cosine of x. And I'm going to do x is cosine of y. Okay? That's what cosine x looks like. That's what cosine y looks like. All right? But that's not a function, so I need to restrict it. So how would we restrict that? Now, I can't do, like, what I did before, which was negative pi over 2 to pi over 2. I can't do that because you guys see that, like, doesn't pass the vertical line test. If I tried to go here to here, doesn't pass the vertical line test, okay? So the way we do cosine, actually, is we pick this section. It might seem kind of random, but not really. Like 0 to pi, it makes more sense than choosing 0 to negative pi, I think. And this section right here makes it a function, okay? So what we do is we restrict this values for where y is strictly between 0 and pi. And that's the inverse cosine graph. And you can see it on here. If I do, instead of inverse sine, let's do inverse cosine. Okay? And I'm going to go ahead and put this in a zoom trig. You can see it a bit better. Oh, shoot, I just graphed cosine. Inverse cosine. Okay? Now, this actually comes all the way down. I don't know why it's not showing that, but whatevs. Okay, there is a point right there. All right. You can see it if I try to calculate a value at pi. You can actually see that point. Oh, doesn't want to let me see it. All right, fine, whatever. Whatever. Okay, so inverse cosine graph goes, you know the cosine graph starts at 0, 1, so it's 1, 0. And then it goes pi over 2, 0. And then negative 1 pi, and this one curves that way. So that's the inverse cosine graph. So it stays between negative 1 and 1 on the x, but the range is 0 to pi. Real important. Very, very important. All right? Okay, now, tangent's weird. A little bit. Tangent's a little bit weird, okay? So let's do y is tan x. Hopefully you guys all remember what that looks like. Okay, these cool little guys. And then we have inverse tan of x. Okay, now, if I were to flip it over, it would draw a bunch of these all over the place. Like it would do a bunch of, like on top of each other, right? Okay. But on here, this is smart enough to actually restrict it. This can actually go, this whole thing, because this is a function, this one piece. There's no other pieces on the top or bottom, okay? So inverse tangent, actually what inverse tangent has is it has an asymptote here, an asymptote here, because you guys, with regular tangent, it has asymptotes at pi over 2 and negative pi over 2, so inverse tangent would be that way. It goes through the point 0, 0, and it goes like that. And that's actually a function. So the domain is negative infinity to infinity, but the thing we really care about is the range value, which is negative pi over 2 to pi over 2, same as this. The only difference here is sine, it actually has points there, so I use brackets. Inverse tan, it gets really close, but they're asymptotes, so I have to use parentheses, so pay attention to that, okay? What is the point of that, right? What's the point of seeing that? Well, okay, so here's what we're going to focus on real quick. Inverse sine, which, by the way, is the same thing as arc sine. It shows you down here, arc sine, inverse sine mean the same thing. Arc cosine, inverse cosine, arc tan, inverse tan. You can call it either one, I don't care. Okay? Is only defined between negative pi over 2 and pi over 2. Now, if I put that on a unit circle, okay? Actually, let me make these color coordinated, because you know me. All right. Boom, Boom. That means that sine is defined from negative pi over 2 to pi over 2. Okay? You guys see that? On the unit circle. Which means, do we have this written down over here? No, I'll write this down. Inverse sine is defined in quadrants 1 and 4. Okay? Quadrant 1, quadrant 4. That's where inverse sine is defined. All right? Inverse cosine is 0 to pi. Okay? So inverse cosine is actually 0 to pi. So that's defined in quadrant 1 and 2. That one's 0 to pi. And then inverse tan is defined also in quadrants 1 and 4. But notice it can't be like at pi over 2 or negative pi over 2 because that doesn't exist. Because there are asymptotes there. So that's also quadrant 1, quadrant 4. Notice these all are defined in quadrant 1. That's where the positive values are. And then in the negative values are in either quadrant 4 or quadrant 2 of its cosine. All right? Whew. Would have been great if I'd taught you guys this last year, but we ran out of time. Okay, here we go. These first few, straight up best friend chart, okay? You guys got your best friend chart. We know that sine, it's too big, hang on. Actually, hold on. Negative pi over 6 is down here. It's got a reference angle of pi over 6. If I look at my best friend chart, hope you guys have that next to you. I mean, I can pull it out here for you if you'd like. I have it, there, okay? Best friend chart. Erase some of that. So the sine of pi over 6 is a half, okay? Okay, back over here. So it's 1/2, but it's in quadrant 4, ASTC. That's the cosine quadrant, so it's negative. This is regular trig functions. It's not inverse trig right now. This is regular trig. All right? 7 pi over 6. That's here. Whoa. Okay, 7 pi over 6 is there. Reference angle of pi over 6, which is a half, AST. That's also negative a half. Okay, let's do one more. 11 pi over 6. That's all the way over here. Reference angle for sine of pi over 6 is 1/2. T, that's in the cosine quadrant. That's negative. Wow, okay, so 3 different sine of something all equal negative a half. Okay? You guys kind of see what this example is doing, maybe? All these things have a value of negative 1/2. So what's the arc sine of negative 1/2? What's the arc sine of negative 1/2? Okay, well, first of all, I can only have one answer, or else it's not a function because I restricted it. So which answer would I pick? All right? Well, one thing I know is it can only exist in quadrant 1 or 4 for sine, so it could be that. Quadrant 1, quadrant 4, so it's not going to be that. Quadrant 1, quadrant 4, so it could be that too. So how do I decide if it's negative pi over 6 or 11 pi over 6? But what you have to remember is this range thing. This is actually real important, okay? This is this range thing, what it's allowed to be. Well, arc sine can only exist between negative pi over 2 and pi over 2. So which of these angles is between negative pi over 2 and pi over 2? Negative pi over 6. That's what we have to call it. We have to call it negative pi over 6. Even though negative pi over 6 and 11 pi over 6 are the exact same angle, you guys, I can't call it 11 pi over 6 because it's outside of my interval. Okay? So that's kind of how that works. So let's check. Let me kind of teach you how I do these without a calculator. Okay, here we go. Arc tan of 1. Okay, so what I'm thinking is, where does tangent equal 1? And I can get that from my trig chart. Where does tangent equal 1? Well, at pi over 4. Pi over 4 or 45. All right? Tangent equals 1 at pi over 4. Okay. So, remember that tangent is only defined in quadrant 1 and quadrant 4. Okay? So, Tangent can't be over there. All right. And because it's equal to positive 1, it would be up here. So the arctan of 1 is pi over 4. And that's cool. I'm done. When you're dealing with positive angles, they're pretty easy because they're always in quadrant 1. Or positive numbers right here, I should say. When you're dealing with positive numbers, they're always in 1. Okay, let's look at this next one. Arc cosine of negative 1. What am I thinking in my head? Where does cosine equal negative 1? Okay, let's come over here to my trig chart. Where does cosine equal negative 1? Well, you guys, nowhere on there. So I guess I got to look at this chart over here, okay? Now, okay, I'm looking for where cosine equals negative 1. Cosine is the x coordinate. That's right here. All right, that's where cosine equals negative 1. That's here. Cosine is negative 1. So what angle do I call that? Well, I call that pi because it has to be between 0 and pi, right? Cosine doesn't exist down here. And then it's just at the edge there. So the answer to that is pi. That's where cosine equals negative 1. All right. Okay, we're ready to get a little tricky. All right, we know that sine only exists in quadrant 1 and quadrant 4. Sine does not exist over here. All right. Sine is positive in quadrant 1, negative quadrant 4, so it's definitely going to be over there. And if I look at my trig chart, I can say, where does sine equal root 3 over 2 at pi over 3? All right? So I know it's at pi over 3. Whew. It's a lot. Okay. But we need to know what to call it. Now, pi over 3 is up there, so it's actually not pi over 3. Normally, I would call this 5 pi over 3, right? But remember, guys, this is not in our interval. Our interval is negative pi over 2 to pi over 2. So I can't call it 5 pi over 3. You know what I have to call it? Negative pi over 3. Okay? Because I can't, and like kind of here's the reason why. If I'm right here and I'm trying to get to that angle, am I going to go all the way around to get to it? No, because I can't cross through those crossed out parts. I just have to go like this, okay? When I was teaching this in a trig class, we had more time to spend on it. What I would do was I would call these little crossed out parts the zombie zone. Okay, we call that the zombie zone. If I start at 0, how am I going to get to that point? Well, am I going to cross through the zombie zone? Heck no, they're going to kill me. I'm going to go that way to pi. So right here, if I'm trying to get to that point, you know, you guys ever watch like The Walking Dead? Super love that show. Okay, am I going to walk all the way around here to get to my, you know, bestie that I left for the zombies to attack? Nah, man, I'm not doing that. I'm not walking through the zombie zone. I'm walking like that. So I'm going to call it negative pi over 3. Okay, does that make sense? Arc sine of 2. It's not even a thing. I don't really think we can get that. Oh, okay. This is telling me, okay, so that's the zombie zone. Sine, you can only be in quadrant 1 or 4. This is saying, where does sine equal 2? Well, you guys, I mean, if I look at this, sine never equals 2. Sine never equals 2. In fact, sine always goes between negative 1 and 1. So where is sine going to equal 2? Never. This is undefined. Okay? And I can show you on the calculator too. If I go out here, I want to make sure I'm in radian mode, which I am. Very good. If I do arc sine of 2, gives me an error. You know why? Because sine is only between negative 1 and 1. I can't do numbers like that. Okay? All right, sweet. The next few questions are calculator questions, so we can just like bust this out really quick. Arc sine of 0.3, okay? Arc sine of 0.3. That's going to evaluate it for me because 0.3 is between negative 1 and 1. I'm just going to go ahead and write this down, 0.304. And then I'm going to do arctan of negative 5 over 2. So this is in the fourth quadrant, and that's why it's giving me a negative answer, negative 1.190. All right? You guys see that okay? Okay, without a calculator. Oh man, these are nuts. Here we go. starting here. Okay, I'm not going to keep going back and forth to my best friend chart. I'm hoping you have yours next to you. Here's how it works. Sine equals root 3 over 2 at pi over 3. Because this is positive, it's in quadrant 1. And then what's the sine of pi over 3? Root 3 over 2. You might be thinking, duh, right? If I have an inverse function, it'll cancel each other out. It's the same idea as if I take like 4 to the third and the cube root. It cancels each other out. It's the same thing. You got to be careful, though. You got to be careful. All right. So tan of arctan of 3, I can just see that, especially because that's positive and it's in quadrant 1, tan of arctan of 3 is just going to be 3. Okay? Arc cosine of pi over 3, because it's in quadrant 1, this is going to work out real nicely and just be pi over 3. But I'll show you. The cosine of pi over 3 is a half. The arc cosine of a half, well, it's going to be in quadrant 1, and we call that pi over 3. Boom, boom. Okay? Now, here's where this gets crazy. Okay? This is like the very first example that we did on this page. What's the sine of 11 pi over 6? Regular trig stuff, remember? 11 pi over 6 stops right before 12 pi over 6. Reference angle pi over 6. In the C quadrant, it's negative. Pi over 6 is a half. Now, what's the arc sine of negative a half? Okay. Well, sine can only exist in quadrants 1 or 4. It can't be here or here. It's positive in quadrant 1, negative in quadrant 4. So it is here. But the difference is I'm not allowed to call it 11 pi over 6 because you know what that is, guys? That's me walking through the zombie zone to get over there. Heck no. When we do this, we actually have to call that negative pi over 6. And you might be sitting there going, that's so dumb, Mitchell. 11 pi over 6 and negative pi over 6 are the same thing. And you would be right. Except that, okay, check this out. On my arc sine graph, let me go arc sine graph, okay? The point, let's see, if x is, what are we doing, negative 1/2, okay, comma 11 pi over 6. Dude, not on my graph. That's not on my graph, right? But the point negative 1/2, comma, negative pi over 6. Woo, on my graph. You guys see the difference? So that one's cool. That one, no bueno. All right? So we have to, like, switch it around a little bit. I don't know. I hope this makes sense, you guys. It might not, but whatever. Luckily, it's a pretty small topic. Okay? Solve for x. Here we go. If arc sine of that is a half, that's pretty much the same thing as saying this equals the sine of pi over 2. The sine of pi over 2, that's the point 0.01, is 1. Okay, so x squared equals 4, so x should equal plus or minus 2. All right. And that's correct. Yep, plus or minus 2. Okay. The last thing, this is just a little bit more trig stuff, whatever. Okay, here we go. If we know that x is the arc cosine of 2 over root 5, here we go. That means cosine x is 2 over root 5. I'm basically just moving this to the other side. So cosine x is 2 over root 5. Guys, that's positive. Cosine only exists in quadrant 1 and 2. Well, inverse cosine, so I'm going to draw it over here. X is my angle. Cosine is adjacent over hypotenuse, okay? The adjacent side is 2. The hypotenuse is root 5. If I do a Pythagorean theorem, 2 squared plus b squared is root 5 squared. 4 plus b squared is 5. B squared is 1. B is 1. All right. Now, what's it asking me to find? Tangent of x. Tangent of x is opposite over adjacent. opposite over adjacent is 1/2. Okay, using like trick stuff. Okay, now, all of that is going to build one idea that comes from number 8. Y'all ready? Y'all ready for this? Okay, here we go. Given that y is arcsine of x, okay, that tells me that the sine of y equals x. All right. Quadrant 1. Let's say quadrant 1. The angle is y. Let's go ahead and call that x over 1. That's okay, all right? And x over 1, this is opposite over hypotenuse, okay? Opposite over hypotenuse. Got to get the other side. We got to do Pythagorean theorem. This is a little bit weird. Let's go ahead and call this side a. A squared plus x squared is 1 squared. Let's solve for a. A squared is 1 minus x squared. So a is the square root of 1 minus x squared. Okay? So that side, let me just go ahead and call that the square root of 1 minus x squared. All right? Now, this is saying find cosine of y. Cosine of y is, here's the angle y. Cosine is adjacent over hypotenuse, 1 minus x squared over 1. So cosine y is 1 minus x squared. All right? Here's where the entire lesson is going to come together for you. Okay. Use your work from example 8 to find the derivative of arcsine. Whew. Okay. I don't know the derivative of arcsine, so I'm going to rewrite it as this. Sine of y is x. So instead of saying y is arcsine of x, I'm going to write sine y is x because I know how to do implicit derivatives. Go me. All right, here we go. Let's take the derivative of this with respect to x. You ready? Derivative of sine is cosine. Derivative of the inside, because of chain rule, dy dx. And then the derivative of x is 1. So you guys, what's the derivative of this? Well, if I solve for dy dx, if I get this by itself, it's 1 over cosine y. Okay? But hang on. Do you guys see what cosine y is in terms of x? So, can I say that the derivative of arcsine is 1 over cosine y? Boom! That's the entire calculus part of the lesson right there, you guys. We got to memorize the derivatives of arcsine, arccosine, arctan. Guess what? Arccosine doesn't come up that often. Wouldn't worry about it too much, okay? Arcsine, 1 over square root 1 minus x squared. We just want to memorize it. We don't want to go through that process every time. Holy crap. Now, I can do the same thing with arccosine, and if you're bored on like a Friday or Saturday night, like freaking go for it. You know what I'm saying? And I could do this same process and find out that cosine's the exact same thing with a negative. And then tan is pretty cool. It's 1 over 1 plus x squared. All right? The only thing that this is talking about is just chain rule. It's using u instead of x and multiplying by the derivative, which is just chain rule. So don't worry too much about that. That's just chain rule. Okay, ready? Minute and a half to keep this under 30 minutes. Let's see if I can do it. Here's how we take the derivatives. You guys ready? Okay. I'm going to go quick. The derivative of arctan 2y minus 1. The derivative of arctan, I follow that formula. Okay? And this goes 2y minus 1. And then I multiply by the derivative of that for chain rule. The derivative of 2y minus 1 is 2. Now, this is a function of y, so don't get confused. That's it. Okay? All right, this one is a function of x. Okay, arcsine, I follow this. So it's 1 over the square root of 1 minus something squared. And the something is this. Okay? And then for chain rule, I multiply by the derivative of that. And the derivative of that is 1/2 x to the negative 1/2. Am I simplifying? Heck no. All right. Inverse cosine means the same thing as arc cosine. That one is here. Okay, the derivative at t is -1 over the square root of 1 minus blank squared. That's what goes in the blank. And then I multiply by the derivative of this because of chain rule. And the derivative of ln is 1 over t. I know that's tricky. Hopefully you guys have an idea kind of how this works. We'll definitely be going over this in class. 30 minutes and 30 seconds. That's not bad. You got to give that to me. All right. Peace out, guys.